Well, good morning. Thanks a lot for having me. My name is Michelle Munson. I'm president and co-founder of Aspera. Most of you probably have some idea these days what we do. We create a high-speed data transfer platform and software applications that live on top of that, and deeply involved in the media and entertainment industry because of the plethora of data transfer in file-based form that occurs with digital media today, particularly over long distance and widely varying qualities of internet connections. And the topic that I want to talk to you about today is very timely for us and rather new. And that really has to do with making what are the various cloud storage systems, and by that I mean specifically object-based storage systems that are so abundant today, accessible and workable for access at global distances for large media. Toward that, what I want to do is spend the first part just talking very briefly about what the whole point or the value of these cloud systems is to the industry. And some of these points may be very obvious to you, but I think it's important to get that frame. And then secondly, I want to talk about some of the technology underpinnings of these object stores, and also what the difficulties are then when you combine that with large media access. And then thirdly, I want to talk about a new software platform, if you will, and solution that we created at Aspera and been deeply involved with Amazon and now going into with Azure and some of the other open source object storage platforms to provide a way to get large media content in and out of these object storage systems at global distances with high speed and hopefully seamless access. So just very briefly, why are these cloud platforms so compelling for big media content? Firstly is the idea of being able to scale out compute and storage resources on demand. So instead of having to own everything within your own facility, buy it up front, you have the, if you will, the utility infrastructure at your disposal. And Amazon Web Services, of course, is one of the most familiar, but in a way, any private cloud you might deploy would be similar in that a multinational corporation could share in the resources that are offered through that private cloud on demand without necessarily buying it up front. Secondly, that brings to the change in the economics. It eliminates the upfront commitment in terms of buying and financing, and also the complexity of putting in and managing the compute, the storage, and even the bandwidth. And also it allows you to pay then for the resources that you use on demand. And that really is CPUs by the hour. If you use Amazon Web Services, you'll know that you're charged CPUs by the hour, storage by the day, or storage by the gigabytes. And there is really no commitment in terms of your usage. So it brings to a head the idea of on-demand economics. And obviously there are tremendous advantages to that with these highly scalable, sometimes very bursty, global sorts of applications that the industry drives today. Firstly, content creation. Everybody here is involved in some aspect of that. And I wanted to just cite one very significant anecdote. I think most of us probably experience Netflix on a regular basis. One of the drivers for us in doing this is that Netflix does all their transcoding on the cloud. In the past, they've received in all of their content from providers to storage located in their data centers using our software. And they approached us about a year ago and said, we want to go direct to the cloud, which takes out an entire middle step in that process. So part of building this direct-to-cloud high-speed transfer capabilities to allow them to move about 40 terabytes a month of all the raw content that comes in that ends up on the Netflix service and gets transcoded on AWS for the scale-out that allows them. Secondly, also, there's the idea of having mission-critical storage and distribution maintained by someone else, meaning the service level guarantees that this public utility, well, public or private utility infrastructure allow us to achieve that without necessarily having to build and manage it ourselves. And then lastly is monetization, distribution, and media. And certainly one of the most interesting talks I heard on this area was by PBS talking about using CloudFront, which is the Amazon Web Services CDN, for distributing their content as a backup to Akamai. Now, granted, AWS CloudFront isn't quite Akamai, but they were able to use it as a reliable second CDN throughout the world for them at an extremely low cost and with great control over their own quality experience. I don't need to tell anybody in the audience about how big the media is. I think that's very obvious to you. I just point out one thing, which is that if you look at digitized 2K, 4K content, 4K frame files, you may end up with over a terabyte, just a single feature film, 1 to 2 terabytes, and that alone, let alone the explosion of numbers of such films, TV shows, etc., that constitute the explosion in the media that needs to be manipulated in these ways. And then, of course, you all know that by virtue of the way the supply chain works now, we've got all this opportunity to move this stuff around between organizations seamlessly over IP networks. In the cloud world, the whole idea is to replace some of these enterprise pods with the cloud infrastructure, and by definition, it's distributed. It's away from you. So you have the opportunity to use low-cost internet access to get the content to and from, but then you've got to solve the problem of the bottlenecks associated with that, all the way into the cloud-based storage. So within this world, there are many options, and you've probably seen these names and logos before. Some are open source, some are private commercial offerings. You've probably heard of the Hadoop project from Apache, which is a underlying distributed object storage that was developed originally at Yahoo, or at least brought into the mainstream through Yahoo. Obviously, Amazon Web Services is known worldwide at this point, the leading cloud offering commercially. Windows Azure is Microsoft's competitor to that. There are also specific niche offerings, companies like Joyent, and there's the OpenStack initiative, which builds upon some of the Hadoop and open source past in terms of building open source object storage infrastructures. So with these, I want to just spend a couple of minutes highlighting what is the technology nature of these, and why does it have so much incongruity with large media. Firstly, these are object storage systems that are derived from object storage as it came to be in the 1990s. There was a group out of Carnegie Mellon that was one of the real, if you will, innovators and champions of this kind of approach. In these storage systems, data is stored as an object, if you will, where the data bytes itself are then referenced through extensible metadata, and allows for a highly scalable and also application-rich way of dealing with large amounts of data. And then there was a wave of object storage platforms that grew up in the internet era, starting first with the Google file system, beginning back in 2001, just to meet the search needs that Google had. Following on with Hadoop, and then on into Amazon S3. And I didn't have time today to go into this, but it's really interesting to look at what these object storage advantages are. Because of the decoupling of the metadata from the object data itself, and the fact that it can be so widely distributed, these platforms are also highly conducive to parallel processing. Right? So you can imagine, if you've heard this term map-reduce algorithms, what that really amounts to is approaches where these object stores are then operated on by parallel algorithms that have many workers that work in parallel on small, simple tasks, like document search, for example. So you've got a partnership between this distributed object storage and its massive scale, and this sort of highly scalable parallel processing that grew up with this last decade of the internet. And Amazon's Web Services today is a exploding store of objects. It has 449 billion, and it probably is even more. This is current as of last fall. There were 1,440 objects for every resident of the United States, 64 objects for every person on planet Earth. So this thing is utterly massive, and it's growing at more than an exponential rate. All this brings me to my basic point for this audience. So on the one hand, you have the scalable distributed object storage. Ought to be fantastic for massive distribution, large amounts of media content, files, you name it. But the problem is these are designed for small chunks of data. So the typical chunk sizes that these object stores rely on are 64 megabytes to 128 megabytes in size. So if you're storing a terabyte file in this, it's broken up into 10,000 chunks. Tom's giving me the signal, I have to be quick. So you can imagine what this means in terms of complexity and performance implications to massive media files, right? And I'm going to move through this. There are two big bottlenecks that come up when you're moving the big stuff in and out of these things. One is over the network WAN, right? And you've heard me talk about that hundreds of times before. HTTP is the standard access mechanism in and out of these things. It's slow at distance, unreliable at distance due to TCP performance at distance. The second and less known bottleneck is directly into the object store locally, such as between EC2 and S3. And that's because the only access there is this chunked sort of multi-part put and get of large file content as individual tiny pieces over HTTP. So if you want to maintain high-speed end-to-end transport from some point around the globe to and from these clouds, you have to deal with both of these bottlenecks, okay? And so they're very severe. If you look at at global distance, you probably have heard me talk about before, you're looking at a tenth to maybe 100th of the capacity that you could have in terms of speed. And similarly, the second bottleneck is a problem. And let me just fast forward here. I want to show you about this. That second bottleneck itself can be reduced between 10 and 100 megabits a second. And I'll give you a good example. If you use a fuse driver for file system access to AWS, the throughput on that is around 100 megabits a second for copying data, right? So here you might have a gigabit WAN, and your I/O throughput of just getting data just in that local storage access and how these are built might be limited to 100 megabits a second. So just to wrap up, what we've done at Aspera, and what I think is interesting here going forward, is we've built a stack that bridges directly into the fast transport for object storage in general. It allows us to go end-to-end, maintaining Aspera speeds over the WAN. We are now in our second beta release of this for our core server software, and we're going to be going into general release in the next month or so for all of our transfer products. And it means you can move media data of any size, maintaining high speeds in and out of AWS seamlessly using this software. Also, the security and the user experience is transparent. So for an end user, it looks like just another endpoint of transfer. So I know I've already gone over my time, so I'll wrap up there, and if you have any questions, I can talk to them later. Thank you. Thank you.